Good afternoon. These are the solutions to your final exam review. I have picked one of each type of problem. So I've labeled which ones I am doing. So if you can look right here, this is problem number 1, problem A. And I'll do that for all the different ones, but you do need to kind of pay attention because I don't have all of them solved, but I do have one of every type of problem. There's one or two that maybe I have two, but in general, it's one of every type of problem. Please don't hesitate to let me know if you have any other questions. The solutions or the answers to all of the other problems are uploaded online. So you do have access to all the answers. And then you've also got the solutions to each type of problem. So let's get started. So the directions on the first set are perform the indicated operation and simplify the result. So we are simplifying here. And anytime that we are simplifying, we are not solving for x. Okay, the directions are simplify, so we are not going to have an answer that looks like x equals 2. We're not going to have that because we are simplifying. You're going to have answers that have x squared in them. It may be a string of things added together, various things raised to an exponent. So that is what we are doing here. We are combining like terms. That's what we're doing when we're simplifying. Now, this subtraction sign right here, that is where students make mistakes on this type of problem. That subtraction sign must be distributed. It must be distributed. So I am going to write down my first trinomial. So 4x squared minus x minus 2. That stays the same. But then this subtraction sign belongs to everything there. We have to distribute that. So it becomes minus 2x squared minus x minus 6. Okay? Now at this point we start looking for like terms. So I have 4x squared and I have minus 2x squared. So I have 2x squared. Okay? The next thing I'm going to look at are my x's. I have negative x here and I have negative x here. That gives me negative 2x. Then I look at my constants. I've got negative 2 and negative 6. So that gives me negative 8. I'm going to take one more look at this and make sure that there's nothing else that I can simplify. I can't simplify 2x squared and minus 2x because the exponents are different. They are not like terms. So this is my final answer right here. 2x squared minus 2x minus 8. Okay, let's move to the next one. Here we are multiplying. We have 2x minus 3 and we have x squared plus 6x plus 10. So what we have to do is we have to take our 2x and we have to multiply it times each term in our trinomial. Then I am going to take negative 3 and I'm going to multiply it times each term in our trinomial. So I am going to work on that right now. So I have 2x times x squared. Then I'm going to have 2x times 6x. And then I'm going to have 2x times 10. Okay? Now my second part is I'm going to work on that negative 3 and I'm going to distribute that negative 3 to everybody. So I have minus 3 times x squared. Then I have negative 3 times 6x. And then I have negative 3 times 10. Okay? Now I didn't, sometimes students will do the distributing and the multiplication in the same step. I did not, just because I really wanted you to see exactly what's happening here. So now I'm going to write everything out together. So I have 2x times x squared. That's going to give me 2x to the third. Then I have 2x times 6x. That's going to give me 12x squared. 2x times 10 is going to give me 20x. Negative 3 times x squared is minus 3x squared. Negative 3 times 6x, that's negative 18x. Negative 3 times 10 is negative 30. Now we're not done yet. Now we have to combine like terms. Now I always like to mark them out as I've simplified them. So first thing I'm going to do is I've got my 2x to the third. There is no other x to the thirds. So I am done with my x to the thirds. So I have 2x to the third, and that's it. Now I'm going to rewrite that 3 because it looks, there we go. That's a little bit clearer. Now I have 12x squared minus 3x squared. Those are like terms because it's the same variable raised to the same exponent. So that is plus 9x squared. Okay. Then I have 20x and minus 18x. So I have positive 2x. Then I am left with a constant. And the constant means it does not have a variable with it, and that's minus 30. Okay, so 2x to the third plus 9x squared plus 2x minus 30. Okay, now let's go on to the next one. The next one we are moving into two exponents. Now, what we have here is we have an exponent on the outside of the parentheses, and this exponent belongs to everything inside the parentheses. Now, I also want you to remember that if I've got x squared and I am raising that to the power of 3, what operation do we do between the exponents? This is a power to a power, and what we do is we multiply those two exponents. So that's going to be 2 times 3, and that's x to the 6th. So anytime we've got an exponent, we are going to multiply those exponents together. So let's go ahead and get started. My numbers are raised to this negative exponent as well. So I have 2 raised to the negative 2 power. Then I have x raised to the negative 2 power. Now y squared. So my y is already raised to a power. Now look over here. We multiplied those. So this is going to be y to the second power times negative 2. Okay, that's what's happening there. Then we have 5 to the negative 2. Okay, and again, now we've got x to the negative 1. And I am going to be multiplying that times the negative 2 because power to a power we multiply. We're going to do the same thing on the y. Y to the negative 2 times negative 2. Okay, now before I start moving things from the top to the bottom or the bottom to the top, I'm going to simplify each one of these because I wrote them out for you to see exactly what's happening. So I'm going to leave 2 to the negative 2, x to the negative 2. I'm not multiplying in either one of those. But for the y, I've got 2 times negative 2. So that is going to be y to the negative 4th. Okay, let's do the denominator. 5 to the negative 2. Okay, then I have x to the negative 1 times the negative 2. That makes that positive 2. So I have x to the positive 2. Same thing's going on with the y. Negative 2 times negative 2, that is going to be y to the 4th. Now, we're going to have tons of movement. Tons of movement. But our x squared and our y to the 4th stays on the bottom. Okay, that stays on the bottom. So we're going to leave that on the bottom. Everything else is going to move. So, first thing I'm going to do is I am going to take this negative 5 and I'm going to move it to the top. So 5, I'm sorry, that was not a negative 5. This is 5 to the negative 2. So that 5 to the negative 2 moves to the top and it becomes 5 squared. So I have dealt with that. Now I'm going to go ahead and deal with this 2 to the negative 2. It moves to the denominator and becomes 2 squared. Okay? Now, let's do my x to the negative 2. The x to the negative 2 goes to the denominator and becomes x squared. That is different than this x squared. Okay? So I'm going to go ahead and write down my second x squared. So I have an x to the negative 2 in the numerator. That becomes x squared in the denominator. Then I have this x squared that's already in the denominator, and so I have rewritten that. So don't lose one of those because they both turn out to be x squared in the denominator. Okay? Now I'm going to deal with my y's, and the same thing's going to happen again here. This y to the negative 4th goes to the denominator and becomes y to the 4th, but look right here. I've already got a y to the 4th in the denominator, so I have to keep that there. Okay, 5 squared is 25. Okay, 2 squared is 4. When I have two terms with the same base being multiplied together, I add those exponents. So that's going to be 2 plus 2. So I have x to the 4th power. Okay, now we're going to do that again with y to the 4th times y to the 4th. That becomes y to the 8th. And that is my final answer right there. 25 over 4x to the 4th, y to the 8th. Okay. Now I have k, and the problem with k is negative 6 times 20, or the square root of 20, I'm sorry. So we read that negative 6 on the square root of 20. Now, the negative 6 is going to stay on the outside. So I'm going to keep that negative 6 on the outside. 20 breaks down. Now, we could break 20 down into 2 times 10, but that does not do me any good because 2 and 10 are not perfect squares. Neither one of them are perfect squares. I could also break 20 down to 4 times 5. And that is helpful because 4 is a perfect square. Okay, so now that I have 20 broken down to 4 times 5, I can take the square root of 4, which is 2, and put it on the outside. Now the negative 6 stays there. That's been on the outside, and I'm left with 5 on the inside. So when I multiply negative 6 times 2 together, I get negative 12 on the square root of 5. Okay, now if you were not able to see that 4 times 5 is 20, like if you weren't clear on what that was, you can always do the prime factorization. So I have 20. 20 breaks down to 2 and 10. And 10 breaks down to 2 and 5. So I have 2 times 2 times 5. And if I put that in the square root, I've got a set of 2's on the inside, so I pull and put 1 on the outside. Okay, so this is the prime factorization, and that is another way to do this. Okay, you would still need to multiply it by your negative 6 because that negative 6 is still there, but we would get the same answer if we did it this way. Okay, I just want to make sure you're aware of the different ways that you can solve that. Now, question number O is the square root of 8 over 5. We can very easily rewrite this as the square root of 8 over the square root of 5. Okay, now there's 2 things that have to happen here. First thing is you've got to simplify the square root of 8. The square root of 8 can simplify to the square root of 4 times 2. Okay, so that's the first thing that we want to do. The second thing that we want to do is we want to address this square root in the denominator. Okay, for something to be fully simplified, we can't have the square root in the denominator. So in order to get rid of the square root in the denominator, you are going to have to multiply by the square root of 5 over the square root of 5. When we are multiplying by the square root of 5 over the square root of 5, we're actually multiplying by 1. And that's what makes it okay. So let's start and do some of these. First thing I'm going to do is I'm going to simplify the square root of 8. So the square root of 8 simplifies to 4 times 2. Okay. The square root of 4 is 2. So I have 2 on the square root of 2 over the square root of 5. Okay. So I have dealt with this part right here. Okay. I've already dealt with that. Now let's deal with that square root in the denominator. So I am going to multiply by square root of 5 over square root of 5. Okay. Now, I can only multiply together the things that are inside the square root. So this becomes 2 on the square root of 10, because the square root of 2 times the square root of 5 is the square root of 10. So I have 2 on the square root of 10. Square root of 5 times square root of 5 is the square root of 25. Okay? But the square root of 25 is 5, and that is exactly what we want. So this simplifies to 2 on the square root of 10 over 5. Now, do you see how this 5 is outside the square root? I'm sorry, this 5 is no longer inside the square root, but this 10 is inside the square root. You cannot cancel those or simplify those because one's inside and one's outside. In order to simplify those further, they both have to be inside, and they're not. So our final answer to this is 2 on the square root of 10 over 5. Okay? Now we are going to move into question number 2. And question number 2 says, factor the polynomials completely. Factor the polynomials completely. Now, I actually decided to do 2 of this type of problem because what happens with this type of problem is that students make it more difficult than it is. Okay, so I don't want you to make this more difficult than it is, because this is actually factoring problems where you already have some of the factoring done for you. Okay, so you don't have to, you do not need to distribute this x or distribute that y. What I want you to focus on is the fact that you have a minus b and a minus b. So that is one of your factors. Okay, so we have a minus b, and the other factor is x plus y. Okay, so all you're doing on this problem is you are looking at your greatest common factor, which is a minus b, and you're putting it right here. Then your other binomial is x plus y. So we're going to do that one again, or one like it again. So for this one, I have y times x plus 2 plus 5 times x plus 2. Look again, you've got this x plus 2 is exactly the same. So you are going to write that down as one of your binomials. Your other binomial is going to be y plus 5. So don't make that type of problem harder than it is. You've already got it, so don't make that harder than it is. Okay? Now, we're going to move on to another type of factoring. This you are going to factor by grouping. The key to looking to factor by grouping is that you have 4 terms. Okay? You don't have a trinomial here. What you have is a polynomial with 4 terms. So anytime you have a polynomial with 4 terms, you can't use the sum and the product or the AC method or any of those things. You have to factor by grouping. Okay? We're going to factor by grouping. That's what we're going to do right here. Factor by grouping. Okay? So the first thing that we're going to look at is we are going to look at 6x to the third plus 3x squared, and we're going to ask ourselves what comes out of both of those. What comes out of 6x to the third and 3x squared? So we have a 3 that comes out of 6 and 3. Then we have an x squared that comes out of x to the third and x squared. So now 3x squared times 2x gives me 6x to the third. 3x squared times 1 gives me 3x squared. Now we're going to look at the second part of this, 2x plus 1. There's actually not anything, and I use that term reluctantly. You are probably looking at this and saying, well, Alicia, I can't factor anything out of the 2x plus 1. There's nothing that I can do with the 2x plus 1. And I would say to you then, what are you factoring out? What are you multiplying by to get exactly 2x plus 1? Some students want to say 0 because they are factoring nothing out. But what you're factoring out is a 1. So be careful there. Do not put 0 there, because 1 times 2x gives me 2x, and 1 times 1 gives me 1. And my answer here is 3x squared plus 1 times 2x plus 1. Now I just want to mention, look right here. Do you see how those are exactly the same? And then I have 3x squared plus 1. So what you're doing when we go back to problem 2a and b, the first step's just already done. Okay, so don't let these types of problems confuse you. That a minus b, it's already been factored out. Okay, so what happened on problems A and B on your review is those are already at this step right here. So don't start distributing and stuff like that. You are factoring. You are working backwards. You are wanting to try and find the binomials that you multiply together to get that. Okay, now let's look at this. This is problem number 2, part H. We have 4x squared minus 25. Now, you have to be able to recognize this as a perfect square. Okay, this is difference of perfect squares. And 3 things have to happen. This has to be a perfect square. This has to be a perfect square. And you have to be subtracting. All 3 of those things have to happen for this to be the difference of perfect squares. Okay? Now, what you look at first is you look at your 4x squared. And you say, okay, what's the square root of that? The square root of 4 is 2. The square root of x squared is x. Okay? Then you're going to say, okay, well, what's the square root of 25? It's 5. Okay? So you are going to have 2x plus 5, and you are going to have 2x minus 5. So you have to be able to identify that as the difference of perfect squares. And the way that you do that is you look for a perfect square here, a perfect square here, and a division or a subtraction sign. Okay? Okay. Now our last one where we're factoring is 12x squared minus 5x minus 2. 12x squared minus 5x minus 2. Now, because we have a coefficient right here, I'm going to show you how to do I'm going to remind you how to do the AC method. And this is because we have a coefficient in front of that x squared. What you do is you take your 12, you multiply it by negative 2, and that gives you your product. So our product for this is going to be negative 24. Our sum remains that number right there, the negative 5. Okay, so our sum for this is negative 5. So I need 2 numbers multiplied together that give me negative 24, and added together give me negative 5. And again, it's a little bit of guess and check. Okay, multiplied together give me negative 24, added together give me negative 5. Remember that because our product is negative, we're going to have 1 positive number and we're going to have 1 negative number. Okay? That's when our product is negative. Our sum is negative means that the larger absolute value of the two numbers is going to be negative. So the numbers that multiply together that give you 24 are 8 and 3. 8 and 3. Okay? Our 8 has to be the negative one because our sum is negative. And when we add negative 8 and positive 3 together, we get negative 5. If you had made the 3 negative and the 8 positive, your product still would have been negative 24, but your sum would have been positive 5, and we had to have a negative 5. So that is important to look at. Okay, so now I split my negative 5. So I have 12x squared minus 8x plus 3x minus 2. Okay, and now I can solve by grouping. So 12x squared minus 8x. I'm going to pull out a 4x. So then I have 4x times 3x minus 2. Okay, and again, for our second set of numbers, it appears that nothing can be taken out, but it's not nothing. You are factoring out a 1. 1 is the greatest common factor. So we have 3x minus 2. So this is one of our factors, 3x minus 2. And 4x plus 1 is our other factor. Okay, good. And remember, those first two problems that we looked at, they just started at this step. So don't make those first two problems harder than they are. Sometimes we like to make problems harder than we are. All of us do. All of us do. Okay. So let's move on to solving. So here we factored. Okay. Remember, factoring is when we break things down. We break things down. Here, our first part was simplifying. Okay, so here, everything that we were doing was simplifying. That is when we are putting everything together. We are adding, we are subtracting, we are multiplying, we are combining like terms. So we have simplified, we have factored, and now we're going to start solving. Okay, solving is when you get a variable is equal to a number. And solving always has an equal sign or you're greater than, less than. So you can have equal to, you can have greater than or equal to, less than or equal to, greater than or less than. These are the signs that you have when you are solving. Okay, so that's what we're going to be doing for the next little bit, is we're going to be solving. Okay, now this is a rational. It's not too terribly bad because we don't have variables in the bottom. But the first thing that I want to do is I want to get rid of my denominator. Okay, I want to get rid of that 4 and I want to get rid of that 3. So if I look at my least common denominator, okay, I would have a 4. I've got to have a 4 in it, and I've got to have a 3 in it. Now, you can leave it as 4 times 3, or you can use it as 12. It doesn't matter, okay? You're eventually going to have to multiply some. You're eventually not. Because it's a number, I'm going to go ahead and use 12. So what I'm going to do is I am going to multiply everything by 12, okay? So I've got a over 4. And I am going to multiply that times 12. And I'm going to go ahead and put the 12 over 1. Okay. Then I have minus 1. If you want to, you can go ahead and write that as a denominator over 1. Okay. So negative 1 and negative 1 over 1 are the same thing. Again, I like to keep that negative sign in the numerator just because that helps my mind. I'm still multiplying by 12 over 1. Okay. Then I have equals to a over 3. I'm going to multiply this term by 12 over 1. And my last is positive 2. You can go ahead and put that positive 2 over 1. And we are multiplying that times 12 over 1. Okay, now I'm going to simplify. And in this step, I should completely eliminate all my denominators. And that's what I want. I want to get rid of those denominators. So here, the number that goes into 4 and 12 is 4. 4 goes into 4 one time. 4 goes into 12 3 times. So I am left with 3a. And that's what I want. I want to get rid of those denominators. Then I have negative 1 times 12. And that's just negative 12. Okay? Then on the right-hand side, I've got a 3 in the denominator. 3 goes into 3 one time. 3 goes into 12 4 times. So now I'm left with 4a. And then I have 2 times 12, which is 24. Okay? So now I have a linear problem that I'm solving. Just got to solve for a. Okay, so first thing I'm going to do is I'm probably going to go ahead, because we're about to do inequalities, so I want to go ahead and practice getting my variables on the left-hand side. I know that makes you a little nervous, but when I do that, it's better for when I have to write things in interval notation. So I am going to practice moving my variable to the left. So I have 3a over negative 4a, which gives me negative 1a. Okay, now I want to remind you that if you decided to subtract 3a from both sides, you're going to get the same answer. So it's completely fine to do that. Okay, now my next step, I've got negative 12. So now I want to add 12 to both sides. Okay, and I'm left with negative 1a equals 36. I'm not done because I have that negative 1 in front of my a. So negative 1a equals 36, and I'm going to divide everything by negative 1. Don't forget to do that last step, and I get a equals negative 36. And that is my final answer. You certainly could check that if you want to. I actually encourage you to check that. We're just not going to take the time to do that right now. Okay? Okay, let's move on. Here I've got, this is E on your final exam review. I have 2 minus x minus 5. Okay, so I am subtracting something in parentheses. So I hope that you're thinking, ooh, I got to do something with that. I hope that's kind of a red flag, that there's something that you've got to do with this negative right here. Okay, so I have 2 minus the quantity, x minus 5, equals 13x. So I have got to distribute this negative before I do anything else. So I have 2 minus x, negative and a negative make it positive. And that's where students make mistakes on this type of problem right here. Okay? Students just make mistakes on that. Okay? So now what I'm going to do is I am going to subtract the x from both sides. Or actually, I'm going to add x to both sides. I'm actually a little bit concerned that my answer on the final exam review is incorrect. Okay, so I have negative x plus x. Those cancel out. 13x plus x, so I have 14 over here. Okay, 2 plus 5 is 7. When I subtract on both sides, I get 7 over 14. And when I do that, that is 1/2. Now, on your final exam, it's got negative 6 written down. And I actually don't think that's right. So let's go ahead and check this just to make sure, because I need to fix that on your final exam answer sheet, or final exam review answer sheet. So let's check this. So I have 2 minus 1/2 minus 5 equals 13 times 1/2. Okay? 1/2 minus 5, that's really 1/2 minus 10 over 5. Okay? So 5 over 1 and 10 over 2. That's going to be 10 over 2. Okay? I apologize. I'm a little rattled because the questions that I wrote down the wrong answer. Okay? 13 times 1 is 13, and that's over 2. So what I have done is I'm checking the 1/2. So I have 1/2 minus 10 over 2 that is going to be negative 9 over 2. And I am going to have 2 minus that. Okay. 2 minus negative 9 over 2, that becomes plus. 2 plus 9 over 2 is the same thing as 4 over 2 plus 9 over 2 equals 13 over 2. And that is a true statement. So the answer to this is 3E, is not negative 6. And that's what's written on your answer sheet. It is actually x equals 1/2. So I apologize for that. Sometimes when you start doing lots and lots of work, you make mistakes, and that's what happened. I made a mistake right there. Okay, so that is 3E, and the answer to that is 1/2. Okay, let's look at number 4. Okay, this is 4B. This is when we're solving inequalities, okay? And this is also when we are going to put our answer in interval notation. Interval notation. Okay, that's what's happening, interval notation. So I have 3 minus 2x is greater than or equal to negative 21. So I'm going to subtract 3 from both sides. Okay, don't lose that negative. Don't lose that negative. So I have minus 2x is greater than or equal to negative 24. Then I am going to divide both sides by negative 2. Now, I am dividing both sides by negative 2. This number that I'm dividing by is negative. That is when we flip the inequality sign. So I have negative 2 divided by negative 2. That's going to cancel out, and I'm left with x. I have to reverse that sign. So x is less than or equal to negative 24 over negative 2, which gives me positive 12. Okay? So x is less than or equal to positive 12. Now, I have told you guys the way to get it correct with interval notation is to graph it first. That is a big help. So 2, 4, 6, 8, 10. I need one more. Okay. Okay, so here is positive 12. I am going to put a bracket because of the or equal to, and I am going to go towards negative infinity. So graphing it really helps you put it correctly into interval notation. So then I have negative infinity to positive 12. Negative infinity to positive 12. Okay? So that is interval notation. So remember, you use parentheses when the number is not included. Okay, when your number is not included, that's when you have greater than or less than sign. And you use brackets when your number is included. And that is when you have greater than or equal to or less than or equal to. Okay, let's do 5. So now we are still solving because we've got that equal sign. And the direction state is solved, but now we are solving rational equations. So the way that we solve rational equations is just like we did 3a. We are going to multiply both sides by the least common denominator. So the first thing I have to find is my least common denominator. So I'm going to start with 2x minus 1. 2x minus 1. Okay, then I'm also going to write down x plus 4. Because those are not the same. And I have to make sure that both of them are accounted for. Now, just like we did in 3a, I am going to multiply everything times my LCD, which is 2x minus 1 times x plus 4. So I'm going to multiply both by that. So I have 5 over 2x minus 1 times 2x minus 1 times x plus 4 over 1. And that equals 3 over x plus 4 times 2x minus 1 times x plus 4 over 1. Now I simplify. So I have 2x1 in the bottom and 2x minus 1 in the top. So I'm left with 5 times x plus 4. Then I have x plus 4 and x plus 4. And I'm left with 3 times 2x minus 1. I simplify by distributing. So I have 5x plus 20. Then I have 6x minus 3. Okay. Now I'm going to go ahead and move that variable to the left. Just because it's a good habit to get into when we are doing inequalities. Okay, you certainly don't have to, but I'm going to model that because I think that that's important. So I am going to be left with negative 1x plus 20 equals negative 3. I subtract 20 from both sides, and I am left with negative 1x equals negative 23. I'm not done, because I have that negative 1x that I got to get rid of the negative 1. So now I'm going to divide by negative 1. And my answer is x equals positive 23. Now, some students will say, but Alicia, can't I cross multiply on that? And the answer is yes. On this particular one, you can cross multiply, but on other rational equations, you can't. So I want to make sure that you know how to do it by multiplying by the LCD, because that works on everything. Okay? Now we're going to move on to number 6. Number 6 says, perform the polynomial long division using the method of your choice. Okay? Now, I'm going to do it using synthetic division, because synthetic division, I think, just works better. If you need any help with long division, I'm happy to do that as well. So when we are doing synthetic division, I take each one of these coefficients and constants. That's what I put in. So I have positive 4, negative 21, positive 3, and 13. Okay? Then this is what I'm dividing by, is x minus 5. I'm going to set x minus 5 equal to 0, and I'm going to get x equals 5. That's my solution, and that's what I put over here in the box. Okay, so my first step, I bring down the 4. 5 times 4 is 20. Negative 21 plus 20 is negative 1. 5 times negative 1 is negative 5. 3 and negative 5. Okay, 3 and negative 5 is negative 2. 5 times negative 2 is negative 10. 13 plus negative 10 is positive 3. So we do have a remainder with this. We have a remainder. So again, there's another mistake on your page. I caught the second one, but I didn't catch this one. So this is going to have a remainder of 3. A remainder of 3. And we didn't do a lot of those in my class when we had remainders. So I will go back and check that. So the answer to this is 4x squared minus 1x minus 2, and we have a remainder of 3, and we put that 3 over x minus 5. Okay, so that's the final answer to this. Now I'm going to go ahead and do this in long division also, just so that we can look at it and you can see it done in that long division. Okay, so I'm going to erase all this, and we're going to do it long division. Okay, here we go. So I have 4x to the third minus 21x squared plus 3x plus 13. That goes in the box. Outside the box is x minus 5. So I ask myself, x times what gives me 4x to the third? X times what gives me 4x to the third? And the answer to that is 4x squared. Okay? So now we take 4x squared and we multiply it times negative 5. So that is going to be negative 20x squared. Then I have 4x squared times x, and that's going to give me 4x to the third, which is what we want. Now, the place that students make mistakes, this is where they always make mistakes with long division. They forget that we've got to subtract these. They forget to change the sign. So that is super, super important that we've got to remember to change the sign. Okay? So I've got negative 21x squared plus 20x squared. That is going to leave me with negative 1x squared. Okay? The 4x to the third and the minus 4x to the third cancel out. So now I'm going to bring down my 3x. Okay? So I am plus 3x. So I ask myself, x times what is going to give me 3x? X times what is going to give me 3x? And that is going to be x. No, it's going to be 3x. Sorry. 3x. X times 3. Oh! Okay. I'm going to have to stop recording and come back to this. Sorry, I'm rattled because I found a second mistake. So I'm going to stop recording, and I'm going to come back to this one. That'll be the first one that I start on my second recording.